Hey, hello everyone, my name is Ganesh Chandra Sahu, and in this video we are going to discuss about one important reaction which is called DARZEN's process, okay, which is called DARZEN's process, and this reaction is very important for your IIT JEE, NEET and also for your board examination. So without any delay, let's start the video. So what is DARZEN's process? Let us take one reaction which is called alcohol, okay. Let me take one reaction which is called chiral center, carbon is there, and here I am putting CH3 methyl group, okay. Let's suppose I am taking here hydrogen, here I am taking deuterium, and here I am taking OH. Now this is a chiral center. Can we see? Yes, we can see it is a chiral center. So when this chiral center reacts with the reagent called SOX2, okay, SOX2, we can take, okay, here X can be what? Here X can be chlorine, X can be bromine, or X can be iodine. Is that clear? Yes. So we can't take fluorine because it is explosive, so we can't take this one, okay. So generally we take chlorine, bromine and iodine with SOX2, okay, which is called thionyl halide, okay. What is SOX2? SOX2 is called, okay, thionyl halide, okay. This is called thionyl halide. I hope it is clear. Let us go to the next part, okay. This is the SOX2 and the corresponding product will be like this, okay. C, here it is CH3, here it is, okay, hydrogen, here it is deuterium, and here it is, okay, here it is X. Now this is the production of, or this is the synthesis of alkyl halide compound, or we can say halogen compound, okay, alkyl halide compound. So we have to write some important points about it, so let us write that. The first, okay, the first point is this is the, okay, this method, okay, this method is, okay, the best method. Very important point. This method is the best method for the preparation of, okay, for the preparation of alkyl halide, okay, alkyl halide, okay. So this is the right. Okay, why this is so? We'll discuss one by one, okay, we'll discuss one by one, okay. So here byproducts are SO2 and another one is HCl, okay, associated as SO2 and HCl, and both of these are gases, right, both of these are gases. And one interesting thing is, okay, I generally call it as, okay, PKP, which is called Papa ki Pari, okay, right. So it is like a Papa ki Pari, okay, जो उड़ जाता है ऊपर, okay, right. So it just liberates, or it just evolves from the container. So only the residue part, okay, residue part which is alkyl halide will be remained in the container. That's why this method is called what? This is the best method for the formation of alkyl halide. Along with that, okay, along with that we have to keep one another important point, that is here 100% retention product comes, okay, here 100% retention product comes, okay. So how it is so? Then we have to know the mechanism part, right? So without any delay, let's go to the mechanism part of it, right? Right. So here it is, mechanism part. Okay, right, mechanism part. So when we take, okay, this particular compound we have to take again, okay, again. So I am taking here CH3, which is methyl group, here it is hydrogen, right, okay, here it is deuterium, here it is OH. Now this is a chiral center, and along with that let us take SOCl2, okay. If we draw the structure also, we can draw in this way, so that, okay, we will have some important idea about it. SOCl2, which is thionyl chloride, okay. So what will happen actually, okay, what will happen? So when, okay, when both of this comes together, so the lone pair of OH, okay, the lone pair of O attacks on the sulfur, and which is called an addition product, okay. This is called addition of both of this. That's why this will form an addition product. Let us do that, okay. C, here it is CH3, okay, here it is H, here it is D, okay, here it is O, here it is H, okay, and now this is combined with sulfur. That's why here it is like this, SOCl, and here it is Cl. Now can we see oxygen is having 3 bonds, which is not at all stable. That's why the positive charge comes on it, right? Is everything clear? Yes. Now we will go forward, and what will happen, sir? Okay, what will happen? Okay, I'm so sorry. So there is a small correction is there. Okay, what is that? Yeah. So this is okay. When it comes, it will go like that. Okay, so O comes to this place, O minus. Okay, right, now it is fine. Very good. Now what will happen? Okay, now what will happen? Chlorine is a leaving group. Okay, as we know, this is a very good leaving group, right? This is a very good leaving group. So what will happen? This minuses will come to sulfur, and this leaving group will, okay, will be removed. So from here, what will happen? So here it is C, here it is methyl group, here it is hydrogen, here it is deuterium, here it is, okay, oxygen, here it is hydrogen, right? And now here it is sulfur, and here it is double bond. Now here it is chlorine. Now here we have the plus charge, and what has been removed, sir? X minus has been removed, right? Now this X minus, okay, this X minus will attack on this particular hydrogen, okay, will take up the hydrogen, because oxygen is having plus charge, which is not at all stable. To make it neutralize, X minus will take up the H plus. Okay, after taking the H plus, what will happen? Okay, this electron density will come, okay, to the oxygen. So that now what will happen? See, here it is methyl group, here it is hydrogen, here it is deuterium, here it is oxygen. Okay, now it is neutralized, right? So S, okay, double bond O, here it is Cl. Okay, here it is Cl. Now what will happen actually? Okay, what will happen actually? Okay, if any nucleophile does not come, okay, in the absence of nucleophile, so we have to include this point, which is very, very important. Okay, in the absence of, okay, in the absence of any external nucleophile, okay, internal, okay, nucleophile make the reaction, okay, favorable. Okay, so this particular point we have to keep in mind, that in the absence of external nucleophile, internal nucleophile makes in the reaction favorable. Now what the point is, which one is the internal nucleophile? So here what happens, this chlorine is having what? Lone pairs. Okay, here chlorine will have the lone pair. Now this will show the interaction between the carbon and the chlorine. So chlorine itself acts as a nucleophile which supports the carbon, because what will happen, this electron will jump to here, and this will be removed as SO2 gas. Okay, this will be removed as SO2 gas, so that the chlorine will attach to the carbon to make it neutralize. So here it is methyl group, here it is chlorine, here it is deuterium, and here it is hydrogen. Along with that, the byproducts are SO2 gas, and along with that, okay, earlier HCl gas has been removed. So this is the corresponding product, and this mechanism is called what? This mechanism is called SNI mechanism, because this is not SN2, right? This is not SN2, and this is not SN1 as well, because in SN1 carbocation will be formed. In SN2 what will happen? In SN2 there is nothing. Okay, there is nothing like inversion product. Okay, that's why it is a new type of nucleophilic substitution reaction called what? SNI. Here I stands for what? Here I stands for internal. Okay, here I stands for what? Internal. Now this is a very, very important process which is called DARZEN's process. I hope it is clear. But along with that, we have to keep in mind some other points as well. What are those points, sir? Let us discuss one by one. So what will happen actually? Okay, this green color line, okay, let me show this one. This green color line, okay, is a new bond which is called bond formation. So I will write here BF. Here BF means what? Bond formation. So I'll start showing you, okay, one type of transition state over here, right? One type of transition state. Okay, what will happen? So here it is. Okay, one second, yeah, right. So here it is. Now what will happen, sir? Please confirm that this is a bond formation, right? As I told, this is a bond formation, but carbon oxygen, okay, is bond breaking. This is a bond breaking. Yes, absolutely, it is a bond breaking. Now this one, okay, this one is also what? This one is also bond breaking, right? Bond breaking. So it is a kind of, this is 1, this is 2, this is 3, and this is 4. This is a 4-membered ring. Okay, here we have to keep in mind it is a 4-membered, okay, it is a 4-membered concerted system. Okay, these are the important terms we have to write. Key, this is a 4-membered concerted system is formed. Okay, 4-membered concerted system is formed. Okay, very very important point. So this is the thing we have to keep in mind. Okay, right sir. After that, what will happen? Okay, this is a 4-membered ring is formed. Now this is the internal. Can we see? Okay, can we clearly see, sir? Okay, here it is a, okay, let's suppose if it is a chiral center, if it is a chiral center which is carbon, is already there in the question. But can we see, sir, this sulfur, okay, this oxygen is also having what? This oxygen is also having a chiral center. Okay, chiral center. Let's suppose this is a fixed center, okay, fixed configuration. Let's suppose I'm telling R. This is just general R, it can be S as well. Okay, I'm just taking it randomly. If it is R, okay, there is a chance one time if it can be R, or the next case it can be what? S as well. Okay, it can be S as well. The first combination, okay, if the first combination is R, then the other combination will be R and S. Is that clear? Because this one is fixed, but this one is not fixed. Okay, that's why it can be R or it can be S as well. For that reason, okay, both of this combination can be called as diastereomer. Okay, diastereomer. Okay, very very important. This is called what? Diastereomer. Okay, diastereomer. So it has the chance of making what? Diastereomeric conformation. Okay, sorry, I mean diastereomeric, okay, isomerism. Right. So these are the points we have to keep in mind, sir. Okay, I hope this one is very very important. I hope you got the product over here. Okay, so let me write, okay, one important point over here. In the case of pyridine, okay, in the case of pyridine, okay, what will happen? So before that I have to make sure another point. What is that another point, sir? Can we see, sir? Can we see? Okay, can we see here? 1 second, let me change the color of it. Okay, right, which color we have to take now? Yes. Okay, now can we see in this way? Okay, so here, okay, here this part, okay, this part is SO2 which is getting left from the, or which is getting removed from the particular compound, and Cl is also going like this. So there is a same direction of, okay, okay, we can write here same direction of removal of, okay, removal of leaving group, I mean removal of SO2 and attacking of Cl minus, okay, to the carbon. Okay, that's why okay, 100% okay, retention product is formed. Okay, the retention product is formed. Very important point. This is one. In the case of pyridine, what will happen now? In the case of pyridine, interesting thing is, okay, 100%, okay, I mean sorry, okay, in the case of pyridine, inversion product, okay, inversion product is, okay, is formed followed by, okay, the interesting thing is SN2 mechanism, followed by SN2. It will be no longer SNI, it will be SN2 mechanism. So this is a very important point, okay, we have to keep in mind, right? So in the case of pyridine, inversion product is formed followed by SN2 mechanism. Okay, SN2 mechanism. So this is the thing we have to keep in mind, okay, very important, and this is all about the Darzen's process. So this one is, okay, as we told that these are the things we have to keep in mind. Number one is this method is the best method. Already it is a very famous question. 100% retention product, as I told, we could know from the mechanism part. Okay, so this is the thing. Let me clear this point. Key, this one, okay, this one is the RDS step. Okay, this one is the RTS step. Okay, and okay, after that removal of SO2 gas and removal of HCl gas occurs. Both of these are gases which will be removed from the container. Only the residue part will be remained. That's why this is the best method. And as I told, this shows diastereomer. But in case of, okay, but in case of common sense, okay, if it is not a chiral center, okay, then come to this point. I just let me highlight this point. If it is not chiral, okay, if it is not chiral, then in this particular, this is not chiral, but only this part is, it can be R, or in the next case it can be S as well. At that case it shows enantiomer, not the diastereomer. But when we take the chiral center of substrate, then it shows diastereomer, right? This is also very important question. So okay, let me do one question, this one, okay, let me try this one. Okay, you just try by your own, okay, and I'll write that. So in this case, okay, OH is there. So in the first case, SOCl2, simple SOCl2 without any base and all, okay, without any base and all. So if you don't know, the pyridine structure is like this, right? This is a pyridine structure. Okay, so what will happen here? Simple, okay, here it is CH3, here it is OH, here it is H, here it is D, and here it is H, and here it is CH3, because same side, we can write here 100% retention, okay, same direction, okay. But when we take SOCl2 with pyridine, then the product will be opposite, simple, okay. Here it is OH, here it is H, I'm sorry, yeah, here it is Cl, right, here it is Cl, okay, yeah, here it is Cl, okay, right, here it is Cl, yeah, right, here it is Cl. Now what will happen here? So here it is D, here it is H, here it is CH3. Now this is 100, inversion product, okay, inversion product. Right. So this is the corresponding answer of this question. In this way we have to do, right? Let us go to the next question we have. Okay, what will happen here? Let me go through the mechanism part only. So here it is like this, here it is like this, here it is O, okay, O, here it is H, here it is S, double bond O, okay, here it is Br, and here it is Br, okay. So first what will happen here? This is O minus, so it will come like this, it will go like this, right? So what is the thing will form? Yeah, double bond is also there, right, O, here it is positive charge, here it is also positive charge, here it is hydrogen, here it is this, S, double bond O, here it is Br. Now what will happen? H plus, okay, electron will come out, H plus will liberate, so H, X will be removed now. So what will happen? Here it is, okay, right, O, here it is S, here it is double bond O, here it is Br, okay, here it is Br, and here is the double bond is there. So what will happen? The interesting thing is very important, okay, new reaction, okay. So let us understand this from the question only. So here it is, the lone pair is present, right? What will happen? This will be donated to here, and this will come out like this, okay, come out like this, and this bond will be breaking and SO2 gas will be removed, okay, SO2 gas will be removed, and the final product will be like this, okay, write that like that. So here it is double bond, and here it is Br, okay, right, sir. So this is the new reaction we have to know, okay. This compound is called allyl, okay, allyl alcohol, okay. So we have to keep in mind allyl alcohol when the OH is attached with sp3 carbon, and after that sp2 carbon must be present, then they are called allylic alcohol, okay. If the OH group is directly attached to the sp2 carbon, then that is called vinylic alcohol, okay. We should know this one. In the same way, this is also another question we have, okay. We have to do in such a way that, okay, we have to follow the mechanism part again, okay, right. So what will happen here? Okay, O, here it is sulfur, right, double bond, here it is Br. I am writing directly So what will happen here? So this, okay, will be coming like this will be going like this. Okay, let me change the color as well. Okay, one second. Yeah, the lone pair will come out here, this bond will shift to here, okay, and this bond will shift to here, and finally, okay, finally we will get the product like this. Okay, double bond will come to here. Okay, SO2 gas has been removed, and here it is. Okay, one second. Yeah, CH2, here it is, Br. Now can we see one thing, that it is 1, it is 2, it is 3, it is 4, it is 5, it is 6. It's a 6-membered ring. Okay, it's a 6-membered ring, so highly stable. Okay, 6-membered ring. Okay, these are simple small points that we have to remember. Okay, so here it is, and now this is a phenol SOBr to SOCl2 or SOBr to SOI2, whatever. Darzen's process does not go Darzen's process, no reaction we have to write, because here it is highly stabilized with plus M effect. Okay, also shows what? Partial double bond character. Okay, double bond character. So that's why this will not show this particular reaction. If we go to the fifth one, okay, let me keep this one as like this. Okay, oh, one second. OH, okay, here if I add SOCl2, then also my answer will be what? No reaction, because of Brett's rule. Okay, because of what? Because of Brett's rule. So these are the things we have to keep in mind. Okay, very important. Okay, this is all about the Darzen's process. Please make sure that you are practicing all the questions from here. Okay, I hope it is clear. If you have any doubts, please comment down. Okay, I will be more happier to clear your doubts. If this video is helpful for you guys, please like, share and subscribe to my channel. This will be helping out a lot. Thank you. We'll meet in the next video. Bye bye.